Blood Flow Workshop, and as you can see here, this is what we're actually going to be showing, how to create something like this. So what we started with is and let me stop that. And what we started with is we start in what's called Workbench, ANSYS Workbench. And what we have here is an ANSYS Workbench. There's so many different things that you can do. You could do things like um, hydrodynamics, fluid flow, a bunch of different things, more mechanical design stuff as well. But what we're going to use is we're going to use Fluent. And with fluid flow, we're fluid flow and we're showing how blood flows through a vessel channel. What we have is we're showing how we're basically dealing with fluid. And ANSYS Fluent is the best thing to do that. But first, what we need to do is we actually need to design. So what we do is in ANSYS Discovery, which is in ANSYS Discovery, what we have is we have something where we are designing a blood vessel. So as you can see, we have one surface here, and we create this blood vessel similar to like a 3D model, if you will, and we design it in ANSYS Discovery. You can design this in SolidWorks, in Fusion 360, and import it in. There's no problem with doing that. You can even use 3D Slicer and slice a part of a body and create and then bring it into ANSYS. I know that there's certain things in SolidWorks that do simulations and things like that, and can also do fluid flow as well, but we utilized ANSYS. So we first start with discovery, and then once we design our thing, we will actually go to what's called mesh. After that, in mesh, what we're doing is we're taking the actual imported geometry here, which is actually what we created, right? So we're actually taking this creation, if you will, of this blood channel canal vessel, and then what we're doing is we're actually going to actually name certain things on this design. And what we have is, so we have our inlet, which is going to let blood in. We have our outlet, which is our left outlet. We have our big right outlet, which is on this side over here. And then we have our main outlet of blood, which is the end of this vessel. And then we have the wall, which is surrounding everything. After we go ahead and we name these selections, and all we do is basically select, we have a tool where we can select, you know, just this portion, that portion, that portion, and that portion, and we name these selections. We can actually like insert a name. See, we can actually insert a name if we wanted to, but we're not going to. We can delete that and hit yes, don't worry. So we can do a whole bunch of things, right? So we actually will name these selections, and after that, we can obviously update. And it takes a little while to update, and then what we can do is we're going to go to setup, and then after we get that, we can actually see more of what we have. In setup, we're actually going and we're setting up the material. So what are we using? Are we using air? Are we using blood? Are we using, what type of material are we using? Which is really, really, really interesting. So if we refresh that and we go ahead and we update this, So like I said, and then we're setting up like viscosity of the blood, a lot of different calculations, making sure that we're actually getting more of a realistic and accurate blood flow through like a blood vessel and really simulating. So this is more of a simulation to show you kind of what we're getting. You can obviously see progress here if you wanted to, which is nice. All right, and then after that, what we do is we can update this, we refresh this, we update that as well. Close this out in a minute. So let's close this out. And the results are going to reflect how we have this viscosity set up and the blood flow. Now there's about three things that we can look at when we look at the simulation for the blood vessel. We have our streamline, we have our isolate, and we also have our contour. And you will see that in just a moment, taking a little bit longer. And anytime that you make an adjustment to an ANSYS, now the only problem with ANSYS is anytime that you make an adjustment, you always want to refresh and you always want to update. This way that the model that you have and the results that you get are always up to date with whatever changes you make to the mesh or to the actual design. Let's say I added another channel or another canal to this vessel. If I added another channel or canal to this vessel, what we would do is we would have to go through and actually go ahead and update every single thing, starting from geometry to mesh to setup to the solution, and then obviously the result. The result's actually going to reflect that new channel and canal. So anytime that you actually update the geometry or the mesh or even something in the setup, you always want to restart and reset. It's always something that you want to do. If you don't, then your results not going to reflect any of that, and you're going to get stuff that's going to be completely different. Get completely different. And all right, so let's go to setup, and then we go start. And as you saw, I had double precision. I had 4 selected there. That is for how many CPUs, just how much your computer is going to be using. And then in here, like I said, what we're doing is we're going to build and set up where we're actually going to read that mesh file. And what we do here is we're actually going to set up a visual. You're going to see a visual here that's going to show you inlets and outlets and things like that. This is going to be, and you set up material, like I said, you set up a lot of different things. It's okay. And what this setup uses is it uses a triangle type mesh on the walls and the faces and zones, and then there's nodes as well, and then you have one node, so you could see what's happening here. All of this that's happening here. You can actually see, which is actually really interesting. Let's create a fluid from release to so we have this setting the inlet, blood, and all that mixture, doing uprights. Preparing for display. So, give it a second. Okay, so as you can see, basically you're going to have this kind of setup. So basically you have blood flowing in where the blue arrows are, the outlets are 1, 2, and 3. You have the wall. So what you're doing here is you're going to set up material, and you're going to have fluid, and you're going to have blood, right? So you're actually going to set up the materials. Some things that you're going to actually set up. There is a solid. There is no solids. You're actually going to set up a new fluid, which is going to be air. You're going to use air, and then you actually have where you're setting up motion detection. You're going to set up cell zone conditions, which is fluid, which you're going to select that surface. You're also going to set up the boundary conditions, which is the inlets and the outlets, and you're also going to set up a wall. Okay, so it's a lot of setup in here. You're going to have obviously your reference frames. You have your named expressions and all that. You're also going to have where you're looking at contours. You're going to look at this as well. You do calculation activities, run calculation. You're also going to set up graphics and surfaces and things like that. You're going to set up parameters. You're also going to set up the viscosity of this material. So what you're doing is you're setting up everything that you need to have this actually run in the simulation. Viscosity of the blood, the actual material, is it air, is it blood, is it, and then you're actually, what's your inlets, what's your outlets, what's your wall. And as you set this up, once you set this up, what you're going to get, and we're going to quit, what you're going to get is you're going to go into results. And when we go into results, this is where we actually kind of have, where we can actually see what we're simulating. So what we're starting off here with is basically what I have is so if I start off with nothing selected, let's say I have nothing selected, this is what happens when there's nothing selected. Now I could select, contour, which this is our contour. Our contour that we're creating are basically pressure areas. So let's say, obviously, we understand that our inlet, right, which is here, facing towards us, which if I do this, we can say, okay, inlet is going to be facing towards us. We can actually show what's the outlets, and we can also show what the wall is. But if I show a contour, the pressure that we're going to get through this vessel is going to be where the inlet is. So you're going to have more pressure going through on the inlet. And as it goes through the canal or through the vessel chain, that's when pressure starts to decrease, right? So as blood flows through, there's more pressure coming into your vein or vessel, and as it goes through, it exteriates out, and you have these cooler colors, which is more of the blues, more of your darker purples, and there's areas like this where, see, there's a corner here. This sharp corner is going to get pressure because blood's hitting this corner, and blood is actually going to be hitting this corner as it goes out this canal and out of this one. So you have pressure areas. And what we can do is we can see the volumetric reading. Now this is the velocity. The velocity is literally showing you what's the speed at which the blood is flowing through. And obviously on the outer parts, if I zoom into this, on the outer parts, on the inner circle, okay, inward, obviously you're going to have more speed. As the blood goes further out towards the wall, it's going to be less as fast because you're having where it's rubbing against the outer edge of the wall. Especially here when you see this in the veins or the out channels, you have a little bit escaping through, and then especially here, a little bit escaping through. So you can see that basically you're having more of more speed kind of dissipating. If we do streamline and we see this, we're also looking at, now we're looking at kind of the streamlines of the area that we're looking at. And we can also change it to isosurface. And if I change it to isosurface, you're going to see what this is in a minute when I start doing that. But this is our streamline. And you can deploy, like I said, you could display just the surfaces itself. You can also display the contour, but this actually is kind of where I like to be and see. So this is kind of like the streamline. And what we're going to do is we're going to go ahead and we're going to animate. We have two different animates. We have our isosurface, which our isosurface is one, and then we have our streamline, which is another. And let's set this to 250. And what I'm going to show you is actually how this blood is kind of flowing. So what we can see is we can see as blood goes through this vessel, it's pushing through. In the middle, you see how blood is rushing fast. See, blood is rushing fast, and then you have slower. The ones on the outer edges are slower, and you can see that some escape through the two canals or two channels here. So we're looking at the speed at which blood is flowing through a blood vessel here, and as you can see, in the middle, as they're not next to the wall, they're very quick. It goes very, very quick. And what I can do here is I can even change, we can actually change this. Let's say, let's go and we stop this. Let's say we're going to change some things here. Let's go and do volumetric reading. And let's say that we're going to run this again. So now you can see kind of what we're looking at. So now volumetric readings, we're looking at, remember I said the reds in the middle. Look how quick those reds in the middle are going. And if I get rid of these lines, these streamlines here, and we can stop that, we can do this, we can do a time step animation, a GPU accelerated animation, key feature animation, but you can see if I take away these streamlines here, now we're only looking at the volumetric rendering of this, and if we run this, you're not going to see anything. Why? Because we're not looking at anything now. Now, if I run the isosurface, this is the isosurface. So you can see as blood flows through what actually is happening. And as the blood flows through, you can see how there's split offs from this. A little bit on that last channel, then it goes back through. So we can see how blood is actually going through this vessel. We can see that the larger the channel from the main vein, the more blood is actually escaping. And what we're going to do is we're actually going to show you volumetric, and we're going to actually speed this up a little bit. Let's do 140 so you can see. So this is what's actually happening. Blood escapes, more blood escapes, and then it's out of the main vessel, and then we can go back and show you kind of where those escape patterns were. And that's basically showing you how blood flows through a vein. It's showing you the velocity, the speed at which blood flows through this vein, this designed vein. It's showing you pressure. It's showing you, streamline is showing you how fast, if you were to simulate the blood flowing through, how fast that blood is shooting through the vein and how slow other parts are. Showing you how cells break off. So what we're doing in isosurface, we're actually showing you that there's the bigger the channel out from the main vein, the more blood is going to be released. If it's a smaller channel, not as much blood is going to be released. And that is how you simulate a simulation of blood flow through a blood vessel or a blood vein.